Yeah, so today two cases. The first topics will be perspectives, and second is earthquake measurement. Now we start from earthquake waves. Yeah, here is the picture that we used to study for last week, consisting of the description of the earthquake sources and the mechanism of the wave propagation to our places. For example, because the object is the settlements or the human settlements, human environment. So actually, that when uh, tectonic plate get ruptures, yeah, ruptures and get damaged, and then suddenly the place release uh, energy accumulated uh, by sometimes because there is accumulated energy for sometimes from the tectonic plate that is subducts each other or collide each other, and the energy spread spread it around in everywhere. uh. So the first is called as body waves. So body waves is waves that are traveling from the sources inside the earth. After the waves reach surface, and the the vibration will be propagated to anywhere too, also horizontally, usually going to and everywhere, and we call it surface waves. Okay, so there are two kind of waves: body waves and surface waves. So not only going vertically, but the waves also propagate horizontally, incline, or maybe don't go downward. Yeah. So we call it everywhere. Okay, and so we can see the top here. So and I jump on the last pages. So if we summarize that, this consists of body waves, gelombang badan, and surface waves or gelombang permukaan. And body waves consists of uh, primary wave or P wave, and the secondary wave uh, S wave. Yeah, two types of waves in the body wave. While the surface waves consists of relief wave and love wave. Two of them. You can see from the YouTube or other sources what the wave animation. Okay, and then we continue our picture here. This is the sketch for the wave propagation mechanism from the focus. Actually, that the focus is not rounded like this one, but the the focus could be space, yeah, three dimensional shapes, yeah, because this is the damage of the tectonic plate. Yeah. Okay, so going round and everywhere the waves propagates, yeah. Some of them reach the surface and transfer to the uh, the form of surface waves. Okay, so body wave and surface wave. Okay, and in another forms of explanation, it could be this is like 500 kilometers. uh, So there is a propagation everywhere. So for example, this is we call the P wave or primary wave P, and S is the secondary waves. Yeah. So it could be SS and P, AP, and etc. Yeah, because there is a uh, layers on the beneath of the earth. That's right. Yeah. Inside of our earth, there are layers. Yeah, and there are many layers. So the outer space, the outer form of the earth is crust. Yeah? It's very solid, very strong, but beneath it look like a plastic state, and even there is also beneath them also liquid state. And if we have uh, apparatus, or we call it a seismograph here, and put in the surface of the earth, and there, during the earthquake happen, so the vibration could be recorded like this one. So the paper here are moving, and the ball here has pen and ink uh, pointed the pointed ends, yeah, and because of moving left and side, yeah, yeah, side back and forth, side, and the paper here are moving, so there is a form of recording. So if you can see here, the recording could be here, recording here, this one. I'll see the bigger one. It is better to have a bigger one. And here. So, if, for example, this is the typical recording, yeah, of earthquake moving. Yeah, this user call it a seismograph. This is this is apparatus for recording the moving of the earth. Means that the record the displacement of the earth. So for the first thing, that the fastest waves are P waves, yeah, coming for the first time, and subsequently after that, and then arrival of the shear waves, yeah, or secondary waves, yeah, arrival time, and there is a interval time, call it S minus P, mean secondary waves time, and then P times, yeah. There is an interval, and there's also amplitude. There is the biggest swaying or biggest vibration of the earth. We call it amplitude. So always usually are very using second. Right? This is 71 minutes, 60 seconds here. So the earthquake in the place here recorded about 1 minute and a half. Yeah. Okay. And here's the other form of the recording. For example, in the place that about 1,000 kilometers from the place of the earthquake sources, and we have recorded here. So the wave travel faster than the other. That, for example, this is 5,000 kilometers distance from the sources. So this also about 9 kilometers, 9,000 kilometers from the place. Yeah. So the recording here, you can see here that there is a interval become become wider and wider. Yeah. So the time become wider and wider, longer time to reach from the P to S. So it can induce for the calculation of the distance of the epicenter of the earthquake from the station. So earthquake station, we mean there is a sensor for record the earth shaking. Okay, this is for example a typical recording of earthquake that we got from seismograph. So for example here from the wave to S wave, yeah, there is interval S minus P equals to 24 second, and put here in the nomogram here and 24 here. So the distance is about 100 210 kilometers. Okay, and they put here the amplitude here, for example, they measure about 23 millimeters, and we put in 23 millimeters from here, amplitude, and then there, that from here we got this one 23 millimeters, as this is about 24 seconds, this equal to 210 kilometers distance, and if we connect it each other, and we'll have a magnitude of 5. We call it, this is the Richter nomogram. Usually the Professor Richter, only Charles Richter, yeah, Richter, yeah, put us only maximum about 6.5 magnitude, yeah. But in reality, that the earthquake could be until 9 or 10 scale, yeah, maximum at about 10, for example. Here, so the rest of this we call it only magnitude. There is no mention about the Richter scale, but the magnitude is only 7.0, 7.9, like that. But if 6.5 or less, for example, 4, we can see that for SR, yeah, Richter scales. Okay, so Richter scale maximum is about 6.5, and the rest we call it only a magnitude or M. Okay, next. There is also another typical recording of the earthquake in earthquake vibration from the sensor forming seismograph. So the first here is P wave, and second wave, all of them are the body waves. And the rest here is the surface waves coming later and bigger and stronger. Stronger. So if we can see here now the waves that in the form of P waves, primary waves. So like this one. So and back and forth, and there is a tension and compression solid the earth, yeah. Pass or the technique bit, yeah, of it have that we now studying. So when there is earthquake, that P wave works like this one. This is the mechanism of the P waves. P waves, yeah. Okay, you can see here, and then back and forth, and it's very straightforward moving. Yeah, so this is very fast actually. The second one is the form of body wave in the form of S wave or secondary waves, or can also shear waves also. Yeah, sometimes because the moving are in shearing. Uh, uh, Not only straightforward, but it could be go side and side and moving forward. So this is the direction of the propagation, and the vertical motion is up and down like that. So actually, that because it's not only up and down, it's up and down if we can see here from our position. But if, for example, from the place of the focus of the earthquake and going to the surface, so it could be that this look like going horizontally too. Yeah. So of course the speed of the speed of these waves smaller than P waves. Yeah. Okay. And if the waves, two body waves mean P wave and S waves reach to the surface, and there is uh, a kind of uh, surface wave. We call it relic wave. So the relic waves. So the motion is look like circle like this one, and the direction of propagation come from here at the side. So there are three dimensions: Z, Y, and X. So going look like that snake, yeah, snake moving, a snake moving, or maybe a caterpillar, yeah, caterpillar moving is not snake, yeah, and going to the call it circling, yeah, circle. So this is the most destructive waves. Yes, the love waves, one kind of surface waves. We're going to very zigzag, yeah, get to right, left and right while going forward. So the particle motion is going here, right and left, yeah, and moving forward like that. So this make most distractions during big earthquake. So lovely. Okay. If we look like to describe using gesture or hand moving, so you can imagine that if the people here going forward, they're working and they bring the circle forward and backward and forward, yeah, while they are working forward here. Then other aspect is going up and down, yeah, up and down, but working forward too. And now about railways look like circle here, and people here also working forward. The last one is the love waves. Also, the people here going working forward, but bringing the circle going to the left or right, yeah, moving. So this is like this is love waves, yeah. Okay, this is the correction of the description of types of seismograph recording. After this is the finish, and then it stop here, right? Because before there is a what we call it, there is a graph here, while the earthquake has stopped, still stopped it here, but it continued earthquake, so it will have a record that it continue also. This is the just the we call it remind you that there are many mechanisms type, types of mechanism of the damaging or moving tectonic plate. going deep here. Then there is a moving up, hanging block, hanging block here, and this normal form. Yeah, this is a normal wave, a normal faulting. This is we call it stack slip faulting, and this one is a reverse faulting. Okay, okay. This is a seismographic recording track, for example, and making vibration here and represent the reflective waves here. We use some kind of experiments. So for the vibration everywhere, and some of them are reflected into this track that have recording, yeah, recording. So for example, there is a horizontal component like this one, and horizontal component this one. So east west, yeah. So this is east west. This is not south. This is vertical, yeah. The top and bottom here, and up and down. So this is the apparatus of the earthquake measurement. Is very complex, yeah. Okay. So this is the type of surface damage. Earthquake, yeah. This is the all long style, yeah, or the simple style of seismograph. There's a rolling here and there's moving horizontally. Okay, and how about the use of the seismograph recording? Yeah, this is it for to find the distance of a station understand to the source of earthquake. For example, this is in the Minneapolis in the Minnesota, Minnesota, and there is earthquake that you use Richter nomogram. Now using digital actually, yeah, by using a machine. So we call this preliminary result. And yeah, and for example, we got but it's about from here are 300 kilometers. So use rounded here using the circle. The yeah, the distance is about r. Here is about 300,000 kilometers. And then from Charleston, for example, this it allowed about 250 kilometers. Just making rounded like this. Because we do not in each of the record, yeah, seismograph, they don't know the direction from where the vibration comes. So they only know they know the distance, yeah. So the distance here, and for example, from Detroit, Michigan, yeah, about 100 kilometer, and put the circle here. So there is a place we call it as approximate epicenter. Because why? Because there are many circle here, a lot of thousands of recording. So there is not simply the exact place, but we use it statistic approach to determine the epicenter. What actually that we need minimum of 3 seismographs recording. Only 2, we can get only 2 maybe. I see still 2 possibility of the earthquake position. Only 1 is very difficult because it's an infinity place. If we have 2, so we have 2, 5. If the 3, it looks like that we have tends to get the 1 point. Okay, we use the law of waves that is very destructive. So this is waves from T0, from T1 second, for example, T second, and T or 3 second. So there is moving propagation there. Okay, so this is the, we call it about the quick waves. Yeah. How about in, you would like to see from, for example, from YouTube, yeah. Here, okay. Here, for example, we just type the keyword. Set quick waves. Art waves animation, yeah. So there's many of them animation of the form the wave propagation. Yeah, before, okay. So there is a different moving here, different mechanism. So for example, this is the P wave, yeah. I mentioned before. Wait a second, it's still not moving. From here, okay, there is in YouTube. I try to type the earthquake with animation here, and I find all those movies is about the waves, yeah, animate. So this is the P wave, kind of P wave in the form of P wave. There is tension and compression. Okay, in sequence, yeah. Okay, this is the secondary waves. This is secondary waves. Yeah, yeah. This wave. Okay. Yeah. This is waves. Yeah. Okay.
Sideways
Next.
at right angles to the direction it
Okay.
is traveling in. In most earthquakes, P waves are felt first. The effect of P waves is bumping and rattling
Right
of
here.
windows.
The
The effect of S waves is an up and down
reporters
and
have
side to
told
side
us
motion,
that
which shakes the ground surface vertically and
we've also
horizontally.
make no damage here,
This is the
but
wave
actually
motion that damages
this
structures of
the
buildings,
positive
causing them to
because
collapse.
there is about that phase.
The third type of an elastic wave is called surface wave and can be split into two types. The first type is called a lobe wave. It moves the ground from side to side in a
Because love waves type of the surface waves, yeah.
horizontal motion. This
Right.
motion particularly damages the foundations of
This is
buildings.
the
The second
love
type
waves.
is
This
called the
is
Rayleigh wave.
the rally
Rayleigh
waves.
waves move vertically and horizontally in a vertical plane, which moves in the direction the
Vertically
waves
and
are traveling in.
vertically, but it's also horizontal.
Scientists have developed a theory
This
which
is
states that earthquakes
it's
are
tectonic
caused by
plates.
plate
This is Indonesia
tectonics.
here.
It also says that Earth's outer shell is split into about 10
Pacific,
larger and 20
Arabian
smaller
plate,
plates.
African
These
plate,
plates move
and
apart, collide, and slide past one another. These An example of plate tectonics
back
is
of
the
the
Peruvian earthquake in
uh,
2007. Peru lost
earthquake.
the plate,
Big
Alaska plate,
earthquake,
and the South American plate. The South American
inhabitants.
plate moved
We call
60
it the
millimeters
human
in the earth
settlement.
towards the Pacific Ocean and
However,
above the
far
North
from the human
Central
settlement,
Pacific.
not unless effect
Earthquakes
is not
can be
that big. Yeah.
detrimental. In
This also the we will also study about learn about discussion about the type of collapse here, like this stories, yeah, soft first story. A lot of first story here in Indonesia actually. The many stop stores, yeah, hyperstore maybe. Um, Store, multi-store, yeah, big store, shopping center, for example, also. Many of them like to have a very spacious the first story for parking space, yeah. So reflects that if there is not good in arrangement of the share component, resistant component, so it will make like this one.
In fact, in most cases they are. In Peru, there were over 2,000 casualties. Scientists have no way of foreseeing earthquakes, as it is not very easy. If you
There's
are in a
also
building
present
during an earthquake,
to drop cover
and hold on. Just remember these steps and you'll have a better chance of being safe.
EGH. This is if the building is earthquake resistant. If not, there is also. So the most important is the building to be earthquake resistant. So there are many explanation for waves, waves. So you can choose which one you like. That's usually are English, but if you would like to find Indonesian version, also you can do that. It's better you use English, increase your English capabilities. There is also Ahmad Gerubang here in Indonesia too. Gempa ya, Indonesian.
The time versus distance graph of PS and surface wave arrival times was constructed by analyzing thousands of earthquakes from hundreds of seismograph stations around the world. Here we show an earthquake near the top of the globe and graph the arrival times to seismic stations at varying distances from the hypocenter. The y-axis shows the distance from the earthquake and the x-axis shows the elapsed time since the event. The seismograms record the arrivals of the compressional P, the shearing S, and the rolling surface waves. Seismic waves travel at different rates, so the farther a seismic station is from an earthquake, the farther apart the P, S, and surface wave arrival times are. Here we show only the direct P and S wave paths through the mantle and crust. The final image of this animation will show more of the complexity within the Earth as waves are reflected, refracted, and damped due to changes at depth. Connecting the waves through a stack of seismograms creates a travel time curve.
So from here we can see that there's explanation about the earthquake come here, and for the first recording, like this one for this sides, second side is there, third side is there, fourth, and etc. until the far here. So this is the P wave coming first, and the second C waves, and the others, and then next will followed by surface waves. But you become the farther and farther, distant. There's more also time to travel. Okay, thanks.
That can be used to locate earthquakes. Simply stated, the time difference between the arrival of the P wave and the S wave can be used to measure the distance from seismometer to the epicenter.
This the time preference, like this one.
PS and surface wave arrival times was to measure the distance from seismometer.
Good, the distance. This is the time traveling. So look like this one. So there is a relationship like this one. If we connect each other, okay. If there's any, there's also in geography subject, subject of geography. Here we can see maybe easier explanation too. Just check this video.
Halo teman-teman, sekarang kita akan belajar mengenai bencana gempa bumi.
Here,
Apa itu gempa? Gempa adalah pergerakan permukaan bumi akibat gelombang yang disebabkan oleh pelepasan energi dari dalam lapisan bumi.
so this is the definition of the tectonic, yeah. So look like this because tectonic are very important and most interesting, ya. Sehingga therefore the people call that earthquake is the tectonic.
Mengapa di Indonesia sering terjadi gempa bumi? Gempa bumi sering terjadi di Indonesia karena letak Indonesia yang berada di jalur pertemuan tiga lempeng, yaitu lempeng Australia, lempeng Eurasia, lempeng Indo-Australia, dan lempeng Pasifik. Tahukah kamu bahwa bumi memiliki lapisan? Ya, bumi merupakan planet yang memiliki struktur lapisan bumi yang terdiri dari lapisan bawah dari tempat kaki kita berpijak sampai kepada inti dalam bumi. Lempeng bumi mempunyai 4 lapisan, diantaranya 1. Kerak bumi. Kerak bumi merupakan struktur lapisan bumi bagian paling luar dari planet bumi. Lapisan ini berfungsi sebagai tempat tinggal semua makhluk hidup. 2. Mantel bumi. Lapisan mantel bumi ini merupakan lapisan yang paling tebal, serta memiliki kandungan magma yang sering kita lihat ketika terjadi erupsi gunung meletus. 3. Inti luar. Inti bumi merupakan bagian terdalam dari struktur lapisan bumi ke bawah, terdiri dari bahan besi dan nikel yang sangat panas dan cair. 4. Inti dalam. Lapisan inti dalam merupakan pusat terdalam dari inti bumi, tersusun dari material yang bersifat pejal atau keras dan ditutupi oleh struktur cairan kental dengan suhu yang tinggi. Lempeng tektonik adalah lapisan terluar bumi kita, terbuat dari suatu lempengan tipis dan keras yang masing-masing saling bergerak relatif terhadap yang lain. Gerakan ini terjadi secara terus-menerus sejak bumi ini tercipta hingga sekarang. Di bumi terdapat 7 lempeng utama, dan lempeng-lempeng litosfer ini mengapung di atas astenosfer. Mereka bergerak relatif satu dengan yang lainnya di batas-batas lempeng, sehingga mengakibatkan gempa bumi, aktivitas vulkanik, pembentukan gunung, dan palung samudra. 7 lempeng besar tektonik di dunia: lempeng Pasifik, lempeng Eurasia, lempeng Indo-Australia, lempeng Afrika, lempeng Amerika Utara, lempeng Amerika Selatan, dan lempeng Antartika. Lempeng tektonik di Indonesia. Di Indonesia terdapat 3 lempeng, yaitu lempeng Eurasia, lempeng Indo-Australia, dan lempeng Pasifik. Tahukah kamu mengapa lempeng tektonik bergerak? Lempeng tektonik dapat bergerak karena kepadatan relatif litosfer samudra dan karakter astenosfer yang relatif lemah. Pelepasan panas dari mantel sebagai sumber asli dari energi yang menggerakkan lempeng tektonik. Kelebihan kepadatan litosfer samudra yang membuatnya menyusup ke bawah di zona subduksi adalah sumber terkuat pergerakan lempengan. Sudah tahukah kenapa terjadi gempa bumi? Ya, karena lempeng bergerak, maka terjadi penyimpanan energi pada lapisan bumi, dan saat tidak kuat, maka energi terlepas dan terjadilah gempa bumi. Batas-batas lempeng. 1. Divergen. 2 lempeng saling bergerak menjauh satu sama lain. Pada lempeng samudra, proses ini menyebabkan pemekaran dasar laut. Sedangkan pada lempeng benua, proses ini akan menyebabkan terbentuknya lembah retakan akibat adanya celah antara kedua lempeng yang saling menjauh tersebut. Contohnya adalah mid-oceanic ridge dan zona retakan. 2. Konvergen. 2 lempeng yang saling bertumbukan satu sama lain sehingga membentuk zona subduksi. Dan jika salah satu lempeng tersebut bergerak di bawah yang lain, akan mengakibatkan terbentuknya palung. Contohnya adalah pegunungan Andes di Amerika Selatan. 3. Transform. Pergerakan lempeng bumi yang mengalami gesekan satu sama lain secara menyamping di sepanjang sesar transform. Contohnya adalah sesar San Andreas di California. Gempa bumi berdasarkan penyebab. Berikut adalah jenis penyebab terjadinya gempa bumi. 1. Gempa tektonik. Gempa tektonik ini terjadi akibat bergeraknya lempeng atau kerak bumi. Tiap-tiap lapisan memiliki kekerasan dan massa jenis yang berbeda satu sama lain. Lapisan kulit bumi tersebut mengalami pergeseran akibat arus konveksi yang terjadi di dalam bumi. Karena gesekan antar lempeng inilah yang menyebabkan gempa, dan ini yang paling sering terjadi selama ini. 2. Gempa vulkanik. Sesuai dengan namanya, gempa vulkanik atau gempa gunung api ini merupakan peristiwa gempa bumi yang disebabkan oleh gerakan atau aktivitas magma dalam gunung berapi. Gempa ini dapat terjadi sebelum dan saat letusan gunung api. Getarannya kadang-kadang dapat dirasakan oleh manusia dan hewan sekitar gunung berapi itu berada. 3. Gempa runtuhan. Gempa ini merupakan gempa bumi yang terjadi karena adanya runtuhan tanah atau batuan. Lereng gunung atau pantai yang curam memiliki energi potensial yang besar untuk runtuh. Juga sering terjadi di kawasan tambang akibat runtuhnya dinding atau terowongan pada tambang-tambang di bawah tanah, sehingga dapat menimbulkan getaran di sekitar daerah runtuhan. Namun dampaknya tidak begitu membahayakan. Justru yang bahaya adalah akibat timbunan batuan atau tanah longsor itu sendiri. Gempa bumi berdasarkan gelombang. 1. Gelombang primer. Gelombang primer disebut juga dengan gelombang longitudinal, yaitu gelombang yang merambat di permukaan bumi. Gelombang ini merambat dengan kecepatan yang sangat cepat, yaitu 7,14 km per detik, dan getaran ini biasanya berasal dari pusat hipocentrum. 2. Gelombang sekunder. Gelombang sekunder atau gelombang transversal adalah getaran yang merambat di permukaan bumi. Akan tetapi, kecepatan gelombang sekunder ini lebih lambat dari gelombang primer. Gelombang sekunder tidak bisa merambat pada permukaan bumi yang cair atau lapisan cair. Berdasarkan kedalaman gempa bumi. 1. Gempa bumi dalam. Kedalaman gempa bumi ini lebih dari 300 km di bawah permukaan laut. 2. Gempa bumi menengah. Kedalaman gempa bumi ini antara 100 sampai 300 km di bawah permukaan laut. 3. Gempa bumi dangkal. Kedalaman gempa ini kurang dari 100 km di bawah permukaan laut. Alat untuk mengukur gempa bumi. Seismograf adalah alat atau sensor getaran yang dipergunakan untuk mendeteksi getaran pada permukaan tanah. Dengan menggunakan alat ini, manusia bisa mendeteksi kekuatan getaran dan arah yang akan dilewati getaran tersebut. Proses gempa bumi. Gempa bumi disebabkan dari pelepasan energi yang dihasilkan oleh tekanan, dan tekanan ini disebabkan oleh lempengan yang bergerak. Semakin lama, tekanan itu kian membesar, dan akhirnya mencapai pada keadaan di mana tekanan tersebut tidak dapat ditahan lagi oleh pinggiran lempeng. Dan pada saat itulah gempa bumi terjadi. Gempa bumi yang paling parah biasanya terjadi di perbatasan lempeng kompresional dan translasional. Karakteristik gempa bumi. 1. Berlangsung dalam waktu yang sangat singkat. 2. Lokasi kejadian tertentu. 3. Akibatnya dapat menimbulkan bencana. 4. Berpotensi terulang lagi. 5. Belum dapat diprediksi. 6. Tidak dapat dicegah, tetapi akibatnya dapat dikurangi. Akibat gempa bumi. Berikut adalah dampak terjadinya gempa bumi. 1. Longsor. Gempa bumi dapat mengakibatkan terjadinya getaran atau goncangan di permukaan bumi yang bisa menyebabkan bencana lain. Dan getaran tersebut juga bisa mengakibatkan tanah
ya, can save it. Okay, and I'll save here. Okay.
Tanah dan batuan keluar dan menyebabkan tanah longsor. 2. Tsunami. Gempa bumi adalah faktor utama yang menyebabkan bencana besar lain seperti tsunami. Gempa yang memicu terjadinya tsunami adalah gempa tektonik. Semakin besar kekuatan gempa, maka akan semakin besar pula kekuatan tsunami. Selain kekuatan, juga seberapa dekat jarak pusat dengan laut. 3. Banjir. Getaran bisa menyebabkan keluarnya air waduk, danau menjadi rusak, sehingga tidak bisa menampung air. Dengan begitu, air akan mengalir memenuhi daerah sekitar yang lebih rendah. 4. Kebakaran. Getaran saat gempa juga bisa menyebabkan kebakaran yang diawali dengan robohnya bangunan. Karena kerusakan pada bangunan akan mengakibatkan terputusnya aliran listrik dan kebocoran tabung gas. 5. Kerusakan lingkungan. Getaran yang dihasilkan gempa bumi dapat merusak keadaan lingkungan sekitar, seperti rusaknya rumah-rumah warga, gedung-gedung, dan menyebabkan terkikisnya lapisan tanah. 6. Kerusakan bangunan. Bangunan yang berada di atas tanah bisa hancur atau roboh karena getaran yang dihasilkan oleh gempa bumi. Semakin besar kekuatan, maka kerusakan ini juga semakin besar pula. 7. Terjadinya korban jiwa. Saat terjadi gempa bumi, seseorang berpotensi untuk terkena runtuhan-runtuhan bangunan yang roboh, atau bisa juga terperangkap di dalam sebuah gedung atau bahkan terseret arus saat terjadi tsunami. Siaga bencana saat gempa bumi. Dari penjelasan bagaimana cara gempa bumi, seperti mengikat bencana. Saat mencarilah tempat, jangan panik. Jika di dalam mobil, jauhi atau kursi dan sekitar.
But mostly can it's better to and
Jauhi bangunan yang sudah retak-retak dan tidak aman.
by using
Bersama, memperbaiki rumah atau kerusakan sarana dan prasarana di sekitar wilayah bencana. Semoga dapat meningkatkan pengetahuan teman-teman semua ya. Sampai jumpa.
Okay, this one is a sample ya. Big and waves. Okay, so now the first part is topic today, yeah, about the waves, big waves. Now we move to the second topics. These are the earthquake measurements. Yeah, measure magnitude, intensity, and seismicity. Yeah, they'll have what magnitude. What is magnitude? Magnitude is the measurement of the earthquake movement quantitatively. Yeah, quantitatively. This is the quantitatively because there is a quantitatively and there is qualitatively. Yeah. Qualitative just is very rough. Yeah, for example, they are good, bad, and enough. Very best like that. But if there is quantitative, there is a number. You can state it by the number, by the indication of number. Yeah. So this magnitude measurement not depend on the distance, yeah. So independent of the distance from the station. Yeah. This one. Yeah. Okay, let's say here earthquake measurement. Earthquake measurement. Let me try if it is still there.
after 3 months, I could understand about 80 to 90% the content of the English news with.
Yeah. So the magnitude. Magnitude 1 to 2 run, yeah. So it's not linear scale, but non-linear. Three, this is magnitude of 3. So this is magnitude of 4. Then again, yeah, edit state. Then magnitude. Say, California, apa, more, 5, level 7, yeah, kali, text, back to the object, yeah, support text. Magnitude, yeah. Big, wow, don't know, yeah. 65 million years ago. Wow. Scary. So this is about the magnitude. This is the measurements of the energy released by the earthquake. Yeah. So the scale is using logarithmic scale. Yeah. So how about if comparison of the strength earthquake? Yeah. comparison is that here. For example, if there is a one grenade, granat, explosive grenade, that's about the 30 grenades, it could result from 1 point scale magnitude, yeah. But if 73 tons, so it's about when the yard, yeah, in the yard of FTSB, yeah, our campus, and there are 73 tons exploded in one time, yeah, and could release 3.5 scale Richter of energy, yeah. Scale by Richter, yeah. This is of magnitude. How about if 5 million tons? It's 6.5. In Jogja earthquake, it's like that 1 million tons. So many grenades, yeah. Maybe 1,000 of trucks grenade, exploded bunch. How about the cluster nuclear weapon? Yeah, 7.7, 7.0. And I will see you the here information.
Ta-da! After 3 months, I could understand about
Skillless work. Yeah. Now it's about intensity. Intensity. There are three. There are three measurement of earthquake. Yeah. Magnitude and intensity, and last is the seismicity. Yeah. The magnitude, intensity, and seismicity. How about the intensity? Intensity is a subjective. This is like subjective measurement or measurement about the earthquake effects. So using the approximation level of shaking in place. Yeah, for example, if there is a Jogja earthquake in 2006, so it tells in many places a different strength. Yeah. Strongest, of course, is close to the epicenter. For example, in Bantul is very strong. Klaten and Prambanan is very strong too. Place there where the crack happened. Yeah. There is only one magnitude, 6.3 something. But if you feel in Bantul, it's like in 9, 8. In Prambanan, about 8. In Klaten, maybe about 7, about 6. Yeah. In Sleman, maybe on 6. 7, for example. In Purwokerto, only maybe 6 or 5. Purwokerto, maybe only 4 and 5. But they use scale of this one, code, yeah, got Romawi, yeah, the Rome code, yeah. There is no comma. If you are using 6.5, 6.3, for example, yeah, there is no comma here because this is just very approximation. The name is modified air kali intensity. Call it IMM, yeah. This one is M for the magnitude, yeah. So it is mathematics equation. You just have to put it back in the italics. Yeah. Italics. This one also italic because this is intensity. Okay. And we will see the
Magnitude and intensity are both related to the size of an earthquake, but they each measure different aspects. Magnitude, which measures the energy released at the source of the earthquake rupture,
yes. German, yeah. Intensity. Yes, different. Okay. Next.
and is calculated using measurements from seismic instruments, is one single value. Seismic intensity, which is the measurement of the strength of shaking at a specific location, determined from effects on people, human structures, and the natural environment, produces a range of shaking intensities in different locations. Thus, unlike earthquake magnitude, which is the same for all locations, the seismic intensity you feel depends on where you are. Intensity is mostly controlled by three factors: magnitude, how big the earthquake was; distance from the hypocenter, intensity varies from place to place; and the local rock and soil conditions. Let's compare magnitude and intensity by using a light bulb as an analogy. The light bulb represents the location within the earth called the hypocenter, where the earthquake begins. The magnitude or size of an earthquake is like the wattage of a light bulb. Just as the wattage represents the amount of power of the light bulb, the magnitude is related to the total amount of energy released by the earthquake's source. The intensity, or shaking level, is like the amount of light from a light bulb at any spot in a room. A small light bulb in one area of a room will make that area bright with high-intensity light, but it will leave the distant areas of the room dim with low-intensity light. So, a given earthquake has only one magnitude, but will produce different intensities of ground shaking, as shown on the USGS Did You Feel It intensity maps.
So there's a different.
But will produce different intensities of ground shaking, as shown on the USGS Did You Feel It intensity maps. The magnitude, as the wattage represents the amount of power of the light bulb, related to the total amount of energy released by the earthquake's source. The intensity, or shaking level, is...
So if you have a bulb, there is a the measurement is called watt, yeah, by W here. For example, 100 W mean watt, yeah. The contour is watt. And for example, this is scale of 6 by 9, like that. And if there is a smaller one, 25, maybe the scale of 5.3. Yeah. So if the bulb put in the room, bulbs put in the room,
is like the
so there is a intensity of the lights. Yeah. For example, the far from the light, of course, there are small intensity. So it's close, and then it's very big intensity. For example, here the intensity with 9 during the earthquake here, and then far from the place become only 8, and then far again and 6, 5, etc. So this is the intensity of the earthquake. So like in the room here, so the farther from, more distant, if you are more distant from the bulbs, from the lights, of course you will get lesser intensity, less intensity. It will be a smaller intensity, biggest intensity. So you get the biggest one. If you are go to the most distant, the most one. Intensity is this one.
any spot in a room. A small light bulb
So
in
here
one
is
area
the
of a room will make
big
that
one,
area bright with high intensity light,
here one,
but it will leave the distant areas of the room dim with low intensity
because
light.
the steam,
So, a given earthquake has only one magnitude, but will produce different
magnitude here,
intensities of ground shaking as shown on the
intensity, because
USGS
the
Did
flash
You
will
Feel
burn.
It intensity maps.
Okay, so you see the difference between magnitude and intensity. Okay. Next, we go to the last one is what seismicity. Seismicity. So the activity of the seismic in the certain places or zones, or region. But this is different from different different place, different time too. Because it's in the same similar time, same place, but in different time it could be different. So I repeat that maybe the seismicity of a certain area during the different time will be different. Seismicity is the overall measurement for the seismicity as for the energy release, energy release. So the explanation of this is very technical. Here is there's a seismicity. That's from the place, there's a relationship and graph the relationship of magnitude and the number of frequency. Okay. Nah, ini there is a look like that is curve here. But if you make it by using semi-logs graph, the magnitude here at the axis is normal, but the ordinate is looking logarithmic scale. So there will be look like that lines, So the curve of the line, this one is the seismicity curve. Seeing because if we convert to logarithmic scale, it will be linear. It will be linear here. So the coefficient of the linearity is B. Yeah. The constant is A. So A and B here is the equation. Like this one, A and B here. This is A, this is and B. Yeah. Plus, in the different pairs, it will be they have different. Yeah. Maybe different place also. We should like this one too. Energy release, of course, the greater is B because this is the area of the energy release. Yeah. So the blue one greater than the yellow one. And A and B maybe there are different similar energy. What? Because there is a different of the strong of the tectonic plate. Different on the tectonic plate. So this is similar energy but different characteristic. A, yeah, there are many small earthquake. Yes, yeah, small, but there is only a small, many small earthquakes, but rarely big earthquakes. While B, small earthquakes are relatively smaller, relatively rare than A. But there is a strong earthquake on B, many strong earthquake. Maybe because of the strong of the tectonic are greater for B than A. Okay, this one, yeah, this is different. So this is seismicity, we call it. If you, I try to find here the seismicity. It's not easy and using YouTube, yeah. Better make a story about that. Ya, seismicity, ya. But knowledge of seismicity. Seismicity curve, ya. Distribution, ya. Here, ya. There is a seismicity here on the place, yeah, and the scale of the earthquake, but we need the graph, yeah, of the seismicity.
Melihat kondisi tektonik di Indonesia, kita sudah sangat familiar dengan adanya sebuah kita masih melihat bahwa profil kegempaan yang relatif dangkal, aksen itu
the location of earthquake, but we need
yaitu subduksi di bagian
equation of the graph, so we cannot
bukanlah di
get solving. So you can see here the curve. The model maybe, yeah. Let me check it. Abstract maybe. So the internet here is very weak. Yeah, it's not easy to get to run this YouTube, yeah. So type in the chat room present, yeah, to make sure that you are follow me now. In the chat, right? Present. Okay, good. Mas Hafiz. How about the others? Okay, said the other ones. You follow me, Mas. Yeah, follow me. Write down on present. Yeah, they're not following maybe and going somewhere. Is that okay? Let me continue using the. Okay, write down up here. IE Boston. Number I got the list and student short name. And to Mas Hendar and Mas Hari. Okay, just one and then saying automatic link list. Automatic introduction. Okay, this is the fifth. Yeah, it's finished. I close it. Save it. Oh,
Yes, sir.
okay, yeah, finished now. It's can be and the material document I'll send later, as usual, maybe tomorrow because I finished for lecturing for the class series are tomorrow. Yeah, so tomorrow I finish the send you. If not tomorrow, maybe Wednesday. I'll send you all the material and the discussion. Okay, so we could stop here. Maybe you will move to another class or maybe another job, another works, another task, and the assignment. and I hope that you stay healthy. And barakallah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
You're welcome. I'll close, yeah. Resume for preparation for next class for you.